Perfect. Well, thank you, Brian. And yeah, we'll look at deploying and testing data migration pipeline with DMS. So let's jump right into it. So first, what is DMS? It stands for Database Migration Service. So we'll have a quick overview over the architecture. So basically, you need to have a source database and a target database. And the rest here, the infrastructure to be able to create that, you first have source and target endpoints. So that's where you have all of the um, uh, configuration needed to be able to communicate with your source database. That it be the location or yes, so that it be the location or the credential. And we also need a replication instance. Replication instance is basically a EC2 that is executing your code. And the last thing is your replication task. And the replication task is basically where everything is happening. We'll get over that in detail in shortly. So as far as the source, I only listed a few here. There are quite a few more than that, but this is a general overview. So for Amazon hosted, you can see we have S3, we have the whole RDS, we have document DB. For self-hosted NEC2, um, basically the self-hosted can also be on-premise. So yeah, you can see you got MongoDB, Postgres, MySQL, MariaDB, and a whole lot more. I would invite you to go to the AWS documentation if you are interested into learning more. And for third party, they also support migrating from Microsoft Azure or certain Google Cloud database. Um, yeah, so what is really important to know is for each database, there are usually some database specific configuration. We'll get over MariaDB later in the demo, like just ways to configure the bin log so that DMS can have access to all the information needed to send your data. And so the source endpoint, as I mentioned earlier, this is where you keep your endpoint configuration, your credentials. So, the URL and database and password and everything needed to be able to communicate to your database. As far as the target, there are a whole lot more than what we have here. I just put a few here that I felt were more important. And mainly, there are two types of um, data migration for the target. Basically, you can either be homogeneous, which means there is no data transformation and you have a lot less control over what will be happening, but it will, and it will also be happen on serverless. It is kind of a fully managed. Let's say if you want to go from Postgres to Postgres, then you can go from any Postgres into a Postgres in your RDS. Same thing, you could go from MongoDB to DocumentDB, and you have also a whole lot of non-homogeneous. And what is important to know for non-homogeneous is that there is still support for some on-premise or for some EC2 databases. But yeah, so for non-homogeneous too, it's not necessarily database per se. So you will have like Kinesis Stream, you have some caching services. So yeah, and you have a whole lot more of AWS services that are supported that can be used as a target. The replication instance, like I mentioned earlier, this runs on EC2. And as you configure your replication instance, this is where you will configure everything going from scaling, multi-AZ, how much memory it has, what's the size of the EC2 that you're using. So it really just configuring the, the, the bare bone of it. And then the replication task, in a sense, this is where everything happens. So you have like different like all of your configuration will happen there. So you have two main type of replication tasks. You will have full load and CDC. Full load basically, when you start a task, the goal is to go from everything that is in database A and move everything to your target database. CDC, you will not transfer everything that was already there when you start the task. It's a capture data change. So it will just bring the new changes as they get created. And there is also a third type that I didn't mention here, but is basically a full load in CDC. So it will start by doing a full load and then it will keep going with the CDC. You can either have them managed. So basically you manage them on your replication instance, or it can be serverless, in which case you don't need to create a replication instance. And as soon as you start a task, AWS will create a serverless instance for you. This is also where you define which tables. You can define some schema transformation. There is a lot more configuration that goes in here. We'll go quickly over it during the demo. If we'd go over all of the feature of the replication task, we'd be here until tomorrow. So let's keep on moving. So in the replication task, this is also where you manage the state of your task. If you start it, stop it, restart, all those things. And this is also where you have access to monitoring. So we'll look in the demo as well. We will go over some of the statistics that you get. So the amount of entries that were moved and how many tables were created and everything. So that's all coming from the replication task. So it does a couple of things. As far as what we have done for DMS, so this is a work in progress. We started that earlier this year. As I mentioned earlier, I joined the team that was already working on it. We have, so far, we can support sources for MariaDB and MySQL. We will support them that they be created by RDS, part of the LocalStack instance, or if they're external. So I will demo, basically, I will have one in a separate Docker container that we will still be able to target. And as far as endpoints, we support Kinesis streams. So we support full load, we support CDC. We do not support yet full load and CDC. And we do support table mappings. And there are a few more features that we support, but it is still a work in progress. We have a full support for table statistics and task statistics. So, well, let's jump right into the demo. So you can see here, this is what we'll be spinning up. It's very similar to the one I showed at the beginning. We have on top here Secrets Manager. So this is where we'll be keeping our secrets. So the database, password, username, the URL, and everything will be kept on a Secrets Manager. And I have extra MariaDB that lives outside of AWS, outside of LocalStack, that will be basically defined in my Docker Compose here. As you can see, Docker Compose is pretty simple. We create a LocalStack container, and we will create also a MariaDB. So let's just go ahead and start that up. That should start. Oh, needs to pull a new image. Always scary for demo. Okay, we'll get this. So let's quickly have an overview of the stack as this is starting. So we can see we'll have a CDK stack that we'll be creating. Also, that demo is available in our samples. If you want, I'm pretty sure somebody will post that in the comment, and then you can run it by yourself. So first we'll create a VPC and a security group to basically allow everything to communicate with one another. And we'll create a role that will be used. I think perfect. We have everything started here. So we'll just start. Oh, let's not destroy anything. I will remember. Yeah, make start. Easy. Okay, so, oh no, not make start. Make deploy. Yeah. There's only 2 commands. I should remember them. Okay, so as CDK will create our stack on our instance here, I will keep going over our stack. It should take around a minute or so. On AWS, create that same stack. It takes somewhere in between 45 minutes and an hour. So this is one of the main advantage of working with LocalStack. So we can see here we're going to create our instance. The instance is pretty simple. It will just be a MariaDB instance. And as I mentioned earlier, there are some database specific parameters that have been created. Here for MariaDB and for MySQL, this is simply just a bin log. There are a few information to enter to make sure that the bin log has all of the information we need to be able to recreate your database. As you might have mentioned too, I did not create a password and username. I will let basically a CDK create that for me. I just retrieve their secret so I can use it later for the source endpoint. For my external database, it is just a MariaDB container. You can see here I'm creating a secret for it. So you always need, for MariaDB or MySQL, you would need to add host, port, username, password, and the database name to your secret for DMS to be able to properly communicate with it. And then we'll go quickly over it so you can see we're going to create our two source endpoint. So we first create a role to our endpoint that will allow the endpoint to get the secret value for our secret. And then we create our endpoint with our secret ARN and our endpoint role. So yeah, same thing. We're going to create. So we create our two source endpoint and a simple Kinesis stream. Important to notice on the Kinesis stream is that we do need to apply a grant read write from DMS. So basically, our role that DMS will assume later, we need to make sure that that Kinesis basically has a policy that will allow it to write to it. And next, our replication instance. The replication instance is pretty simple. We are creating a role. The role name is super important because we cannot attach a role to our instance. DMS will go and look for a role that is called DMS VPC role. And yet the rest is pretty simple. You can see we define if it is publicly accessible. We can define the security group and everything. Oh, yeah. And then, so we're going to create 4 tasks, and that's what will go in the demo. Will be the 4 tasks here. We have a first one will be a CDC, so for change data change, and it will only exist. Will only take databases that starts with the letter A. Just to kind of show a little bit how those table mapping rules happen. Our second one will be a CDC task as well. And it will only include the table novels. And then we have 2 full load tasks. Same thing. The first one only databases that starts with A, and the second one only the novels table. So we'll go over to our stack. Yes, it took 41 seconds instead of 41 minutes. That makes me happy. And we can quickly look. So we can look at our replication task. We can see we have the 4 replication tasks that I mentioned. There's not much to see here. We can see that they are ready and that so that is what we need for now. And next step is to run. So like the demo, I will first do a full load and then a CDC. And I will talk to you through a little bit each step along the way. So we can see here when we're starting the full load, we're first dropping our table just to make sure that there was like nothing left in those in those databases. Then we're going to create a table, insert some data. As you saw, we added one author, we added one account to the accounts table, and we added 2 entries to the novels table. So now we'll start the full task 1. That takes around 15 to 20 minutes on AWS to do. I enjoy those couple seconds. So we can see we start the full load. It went from starting to stopped. So here we go. And now we are reviewing. We received 6 Kinesis events. So I'll go quickly here. We have the drop table, as I mentioned. So we'll have 2 drop table, one for accounts and one for author. Remember, novels is not here because we only filtered for A. And then quickly here, we got control here. That should be, yes, we have another author create table. And then here we have our 2 entries that we added. So that first one here will be what we loaded into accounts, and then what we loaded into authors. You can see all of our data here. So then for the second one, it will be very similar, but we're only going for novels. So as you can see, very similar, but we only have 4 events, which will be our drop table, create table, and then the 2 novels that we added. So we have all of the data here, and those are basically everything that we received through Kinesis. So we can see here, like all of our start replication task, and then we are describing we're getting our records. So that is everything we're getting from here. So that's it for the. Oh no, we still have the table statistics. So quick overview over the table statistics. Basically for the task one, we can see we'll have like each table here. So the table statistics for each table. So that first one here, hard to read always, but you can see we loaded 1 row onto the table account, and here we loaded 1 row onto the table author. And then for the table statistic for the second task, we probably loaded 2 rows onto our novels table. And then second one, just to demo CDC. CDC will work a little bit differently, where what we will do is that we'll first create the table, and then as we start the task, it will first create the table. So we should see some create table happening when we start the task, and then nothing will happen. And then as we will later on basically run queries, we'll seed some data into it and we'll alter some table. Then we will like receive the Kinesis as it goes. So here we see we created the table, and we have all of our tasks are running. So, well, that was fast. So that is the Kinesis event we received. We received 5. So basically from task 1 and task 2, both task 1 and task 2 create a first event that it basically creates a table called AWS DMS apply exception. That's something that happens on CDC for DMS to basically be able to manage its exception and control them. And then we will have as you can see, we have all of our table definition here so that we can recreate those table for all our tables. We have novels, authors, and accounts earlier. And then we can see now we're going to run the precede and wait and grab our Kinesis again. So yeah, it happened. So you see we're expecting 4. It should be there. Woohoo, it happened. So it took a few seconds, but here we basically created all of those in our database, and then we waited to receive them in our Kinesis. And as you can see, we have our create author. We have a new entry in the table novels. We have another entry in the table novels. We have one more entry in our table authors and 1 entry in our table accounts. So this is everything is accounted for. And then for the alter event, there's a lot of alter event. I'm just displaying 3 here just so that we can have a little bit of an understanding. So I'm going to alter the table authors to be a varchar. So it is a column type change event. We'll have a drop column event. So we alter table, drop column, profile picture, and we'll have a add column to our novels table. We basically is stuck. Sure. We have good names. And here we go. So let's fire that up. Yeah, it didn't take too long. Here we go. So we have our 3 events technically. Maybe we can make that screen a bit bigger. Will that help? A little bit. Okay. So we can see we received our 3 events. So we have column email, old table def. So that allows us to have like everything that the table was before the change. We can see email here was a string of length 255, and the new table def email is a string of length 100. And then quickly here we have is stuck. Once again, we'll have is stuck here as nullable, And yeah, we can see it got add column to novels, and our last one, profile picture. If we go down, it got drop column in accounts, and then table statistics are fairly similar for CDC. We can see we don't have the full load rows that we had because it was not a full load. What we have is DDLs or apply DDLs. So that would be the drop column and those things. And then we have some apply insert. I didn't do any deletes and updates, but as soon as we would like modify element or delete or drop element from our table items, this is where it would go. And yeah, that sums it up for the demo. I hope it was helpful. I I'll go. Okay, what's next? So as I said, this is still a work in progress. So we currently have um, other engineers that are working on our serverless. So basically being able to do the same thing, but with serverless, so without having to create a replication instance. And we're also right now working on S3 sources. And as always, uh, well, let us know if your company has more needs for different supports, that it be on different features of the service or added sources or endpoints, targets. And yeah, with that, let's go to a quick Q&A.